Oh boy, hello. Sorry, sorry for absence. Yeah, so I looked it up in the internet. Okay, so and I'm not sure if this guy is well known. You know, you have the secondary acceleration and stuff. So, and if you wanna find out the tertiary acceleration, you know, the constant tertiary acceleration, yeah, you will have to know sigma k to the cube. Okay, and we found that formula, but so I looked it up. Okay, looked it up in the internet, and fortunately, yeah, there's general formula exists. What sigma k from 1 to n, k to the ith or k to the eighth, that exists. That formula exists, and it has been existing for a very long time, like 600 years at least. Okay, so because I yeah, we can rediscover that. Just when what general formula. Okay, general formula like sigma k from 1 to n, k to the eighth. Okay, so if the formula exists, okay, so somebody called Foul, Mr. Foul Haber, and also more well-known person Bernoulli. Okay, is this how you spell his name? Bernoulli. Yeah, they discovered those general formula for this. It's way beyond me. Okay, way beyond my level of mathematics. But they found this like at least 500 years ago. So it's very well known, and but it's very advanced. So I couldn't follow it. It was way beyond me. You have Stirling's number, what Riemann zeta function, whatnot. Okay, I couldn't do it. It was too much. Okay, so but it's good that somebody figured that out. It involves Bernoulli number. Okay, you know, Foul Haber's formula, whatever. Okay, yeah, so it exists. So that's good. Okay. But what we are dealing with here, that's not the same as that, because we are just making use of those formula, what Foul Haber's formula that already exists. Okay, so we just proved when a is special case when a is equal to 3, right? And that's cool. I mean, it was not a brand new discovery, but it was nice exercise. Okay, a nice excitement. Okay, and I'm not disappointed that it formula already exists. Even more general form already exists. Yeah, I'm glad somebody found it because it is important. Okay, so and we don't have to do it because it's already found. Okay, so that's a relief actually. Okay, so yeah, we can just get it behind us now, and yeah, so forced acceleration is second order polynomial, right? Constant acceleration, but we can have increasing acceleration, you know, constant rate. So that's what we call secondary acceleration. Okay, and we can have tertiary acceleration, and on and on and on. Okay, so to do that, yeah, you have to go through process like this, and you need that Foul Haber's uh, formula. Okay, so we'll just leave it at that. Okay, because we went way off topic. Okay, we'll get back to our palindrome number. Okay, Okay, it was nice expedition, nice travel. Let me make sure. Well, I'm gonna just take a picture of this, okay? Because I wrote something here. So, all right. Yeah, yeah. Fowler-Harbor equation, Bernoulli number, Stirling number, 뭐 Riemann zeta function. One, it's all to me. It's too much. Okay, so I'm not gonna do it. I'm not gonna study that, and it's just too difficult for me. Maybe one day. Okay, maybe one day. But we'll just get back to our what our thing that we've been doing. Okay. Just looking at past stuff. Give me 1 second. Try to remember where we were at. Okay, let's just do this. Okay, so um, I stop fumbling around. Yeah, let's just do this guy. Okay. So um, it's a nice exercise. Okay, it's we can approach. Okay, so you have six numbers. Okay, 2, 4, 8, 14, 22, 32. Okay, so what kind of sequence is that? Well, let's just subtract and see if we can see some pattern. Yeah, subtract 2, 4, 6, 8, 10. Okay, it's linear, right? Subtract again, 2, 2, 2. Yeah, so it's a constant acceleration, kind of. Okay, scenario. So yeah, it has to be some second order equation, right? But and we have equation for that, right? Constant acceleration. Yeah, s equal to x s0 plus v0t plus 1/2 at squared, right? Right. We found that formula. Okay, so that's what we've been dealing with. But let's approach it from a different angle. We'll do system of equations, system of linear equations. Okay, so it goes like this. All right, so because we know it's a second order polynomial, you know, the general solution for this, yeah, a to the n is equal to a n squared plus b n plus c, okay? And then we know it behooves us, it's more convenient for us, we have to modify the index, okay? So we have to put this as 0, okay? 1, 2, 3, 4, 5, okay? So yeah, you plug in 0, right? N is equal to 0, it's time 0, n is time, right? 0 second, okay? So yeah, then c is equal to 2. This 2, 4, 8, 14, that's an, okay? So that's the value of the function. And when n is equal to 1, yeah, a plus b plus c, which is 2, is equal to 4, okay? The value of the function, okay? When n is equal to 2, yeah, 4a plus 2b plus 2 is equal to 8, okay? Just system of equation, right? So, and then you divide by 2, right? So 2a plus b plus 1 is equal to 4. Pass that around, it becomes 3, right? Here you have a plus b is equal to 2, all right? Now we got it. C is equal to 2. You subtract these two equations, right? So a is equal to 1 and b is equal to 1, okay? So the formula for that will be yeah, an is equal to n squared plus n plus 2, okay? So when n is 0, yeah, 2. Yeah, forget about this part. This is when and the indexing actually start from 1, okay? So if index start from 0, it goes like it. 0, you have when n is equal to 1, yeah, you have 1 plus 1 plus 2, n is equal to 2, 4 plus 2 plus 2, yeah, it works, okay? But if n start from 1, the index starts from 1, then what we are doing is parallel shifting of this function, okay? You do the parallel shifting, okay, of this function. It's kind of instructional, so we're gonna do it together, okay? The indexing increased by 1, right? So in a function, you have to subtract by 1, okay, in order to preserve equality, okay? So if index starts from 1, yeah, then you do plug in, substitute n minus 1 instead of s, instead of n, okay? So you expand this, then n squared minus n plus 2, okay? That's how it becomes, okay? So when n is equal to 1, 1 minus 1 plus 2, 2. N is equal to 4 minus 2 plus, yeah, that's 4. N equals 3. 9 minus 3, which is 6. 6 plus 2 is 8. Okay, so it's kind of instructional educational thing, okay? Parallel shift, okay? So index increased by 1, okay? Then you just plug in n minus 1 in the original function, okay? So that's how you do it, okay? Because n now is bigger by 1 than previous, so that's why you have to subtract it to preserve the equality, okay? So, okay? All right, good. Now, we can erase all this. Why are we doing this? Because we are doing palindromic number, okay? So, I'm going to have to shuffle this whiteboards again. We are done with this. Okay, we are done with this. We have enough background now. Ah boy. Oh boy. What's next? Hmm. Ah, boy. um. Yeah, I guess I erased the stuff that we need to talk about next. I guess I erased at some point. So oh well. Well, I don't want to erase this yet. Uh, yeah, we can erase it. We can erase it. Yeah, I'm sure I took a picture of this at some point. So yeah, there's this Bernoulli number. Also, there's Carl Jacobi involved in there. All these big famous people, you know. It's way beyond me. Okay, yeah, they're professional mathematicians who lived long, long time ago, like hundreds of years ago, and me. Yeah, kind of shame on me, right? Because it's just too much. Okay, so yeah, I just couldn't do it. Okay, so maybe one day I will study those things and share it with you, or you study those things and share it with me. Okay, whatever. Okay, so we are doing palindromic number, right? So because I erased it, I have to rewrite it. Okay, so we start from zero, right? And 0, 1, 0, and 0, 1, 2, 1, 0, 0, 1, 2, 3, 2, 1, 0. Okay, so the number of digits increase linearly, right? 1, 3, 5, 7. Okay, but the number itself becomes like something like here you have 10 to the first, you have 10 to the 10 to the third, here you have 10 to the 10 to the fifth. Yeah, number itself is increasing exponential fashion. Okay, okay, but what's linear is this exponent, 10 to the first, 10 to the third, 10 to the fifth. Okay, so the exponent, that's linear growth. Okay, that's growing up linearly. Now that's the palindrome number, but what we are dealing with is not just palindromic number. We are dealing with some kind of concatenation of that. Because yeah, it's more complex. Okay, so here it's kind of like some kind of summation, some higher order summation. Okay, so it's like our palindromic number. These are palindromic numbers, right? But our, we can say hyper palindromic number or super palindrome number, whatever. Okay, super palindrome number. Okay, it goes like this: 0, 1, 0, 1, 2, 1, 0, kind of oscillating 1, 2, 3, 2, 1, 0. It goes like that. So okay, so you have what 0, 1, 0, right? We have 0, 0, 1, 0. You have 0, 1, 2, 1. No, 0, 1, 0, 1, 2, 1, 0. Okay, so that's the kind of number we are dealing with. Okay, so it goes up and then down, up and down, up and down, up and down, up and down. Okay, this will be our super palindrome infinity. Okay, so it's a sequence. All right, so because why are we doing this? Well, it's kind of interesting. Okay, so we are just concatenating. Okay, we have this palindrome triangle, right? We're concatenating one by one, one after the other. Okay, so it's that's what we are dealing with. Okay, and what would be the nth number? Okay, that's we'll find out. You know, in this integer land, natural number land. We'll deal with the decimal later because that's more complicated. Okay? Okay? So, our first step is to find nth palindrome number. We need to express that in algebraic expression. We need to find that, okay? And then we can move to the next level, the super palindrome number, okay? We'll that later, okay? What is super palindrome number? It's a linear expression of this triangle, which is two-dimensional, right? We are converting this two-dimensional triangle and expressing it in one dimension. Okay, so it's going to be a very big, very fast-growing number. Okay, we can find some order of magnitude, the big O notation, you know, the growth of this function. Okay, yeah, we can do that. All right. Because it's going to infinity, you know. So when it goes to like infinitesimality, you know, on the other side of the decimal, like point something something. What we are interested in is whether this number converges. Okay, whether it's a constant or yeah, that's what you need. But when it goes to the positive, to the infinity, it gets bigger and bigger. What we are interested in is the speed of this function. Okay, because we know it goes to infinity, but how fast does it go to infinity? Is it like polynomial increase or logarithmic, or is it what geometric kind of increase, like, you know, exponential, you know, that kind of stuff? Okay. All right. So yeah, we're now kind of back on track. Okay, we are back on track. We're dealing with our palindrome number. This one might have been discovered before by somebody, and it's okay. You're just having fun, right? I mean, you play video game, right? Video game. I'm sure before you play that video game, somebody else have played that video game, right? But who cares, right? Same deal. We're just having fun, okay? Brain exercise. That's all we do. We don't have to be first time in the world, okay? That's not necessary. We're just having fun. Oh, yeah. Okay. Let me take a picture of this, okay? It's not that pretty. Not that pretty compared to what we have seen over there. But so we saw some fish scale looking thing over there, right? That was pretty. And now the fish missed the ocean wave so that he can live in this ocean. Sure. Yeah. Okay, we're gonna take a break and we'll be back, okay? Alright. Okay. Okay, we are back. Um, oh boy. All right, so we'll make this happen. Okay. Well, we can erase all we want because it's from here it's easy. Okay, we know what we are dealing with. Yeah, it's a super palindrome number. Okay, so before that, yeah, we gotta find out formula for this just regular palindromic number sequence. Okay. So that's what a. This is A0, right? And A1, A2, A3, right? It is straightforward, right? So A3 is equal to what 10 plus 1 plus 10, 1 times 10 plus, okay, 2 times 10 to the second plus 3 times 10 to the third, right? And then plus 2 times 10 to the fourth plus 1 times 10 to the fifth, okay, right? um I'm a third, okay, so which is equal to sigma, okay, k, well, we use I, okay, I from 1 to 3, I times uh, 10 to the I, right? That's the easy part. The second half is less than half, whatever. Sigma I from uh, let's do one more, okay? A to the fourth, okay, I'm sorry. 0, 1, 2, 3, 4, 3, 2, 1, 0, okay? So uh, that's plus 4 times 10 to the fourth, right? Plus 3 times 10 to the third, okay? Oh, 10 to the it's like this, okay? 3 minus I minus 1, okay? So, well, I guess we can do parallel shifting. So, how about I go from 0 to um, 0 to 2, okay? So that we don't have to deal with all this. Mm, no, no. We stick with old school. Okay, I start from one. Okay, just old school. From one to three. Okay, so it's not too bad. Okay, so just follow along with me. Okay, I minus one. Okay, so okay, and then multiply by 10 to the uh, I plus 2. Okay, it can be simplified as 4 minus I. Okay, okay, so this is 4 minus I. 4 minus I multiplied by 10 to the I plus 2. Okay, so that's that. Okay, and in order to generalize this, uh, we just need to modify probably some constant numbers. Okay, so uh, so um, let's do one more, right? Just one more. A fifth is equal to 0, 1, 2, 3, 4, 5, 4, 3, 2, 1, 0, right? Which is equal to this first half, right? Yeah, 10 plus 200 plus 3000. So that goes like sigma I from 1 to 5 I times 10 to the I, right? Plus sigma I goes from 1 to 4 probably is 5 minus I would assume, times 10 I plus 2. Okay, let's see if this is correct formula. I is equal to 1, right? So, yeah, 4 times yeah, this formula doesn't seem to be correct. Yeah, I'm sorry, I kind of messed up. Okay, so here, because here you have 4 times 10 to the 1, 2, 3, 4, 5, 10 to the fifth, right? Plus 3 times 10 to the 6 plus 2 times 10 to the 7 plus 1 times 10 to the 8th. Okay? 1, 2, 3, 4, 5, 6, 7, 8. Wait a minute. 1, 2, 3, 4, 5, 6. So it should be 6. Sorry. 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so boy. So this should be I plus what? I plus 5? Okay. 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 I'm trying to see why here is I plus 2 and why here is it is I plus 5. I'm trying to figure that out. Okay, so can you read all this? Yeah, you can. Yeah, if I can see this on the screen, yeah, so can you. So trying to find out why this is I plus 2 and here we have I plus 5. I'm trying to see why. Oh yeah, because I start from 1, right? Okay. Let's do one more. Now this time smaller number, okay? A3, okay? A3 is equal to um, sigma. Yeah, we start with the easy stuff from 1 to 3, right? I times 10 to the I, right? And plus sigma of I from 1 to 2, right? Uh, 3 minus I guess. 3 minus I. And multiply 10 to the what? 1, 2, 3, 4. Okay, we have some interesting sequence. Here we have I plus 1, I plus 2, I plus 5. 1, 2, 5. Okay, that's not very obvious to me. How about when A is equal to 2? We have sigma I from 1 to 2, I times 10 to the I, right? Plus sigma I from 1 to 1, 2 minus I times what? 10 to the what? 3. 10 to the 3. So I plus 2? Really? Is this correct? Let's see. 2 times 1, 2, 3, 4. I think this should be I plus 3. A3, right? So 1, 2, 3, 4. 4 and 5. Okay, so 4. I plus 3. Okay, and this guy should be yeah, I'm sorry, I made a mistake. Okay, so 10 to the 5th, 10 to the 6th, 10 to the 7th. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so this should be I plus 4. I plus 4. Yeah, sorry, I made a mistake. Yeah, it's not that difficult. Okay, it's just me making mistakes. Okay, so yeah, it's fairly linear growth. So it's fairly easy. Okay, so we already found a pattern here. Okay, we'll write it out. Okay, a n is equal to sigma I from 1 to n I times 10 to the I plus sigma I is from 1 to n minus 1. Okay, n minus I times 10 to the I plus n. Okay, okay, yeah, we got it. It's very fairly straightforward. Okay, so it's very straightforward. So we're gonna switch out the board and yeah, I'm gonna take a picture of this. I'm gonna switch out the board and yeah, let's see what's what. Okay. Oh boy. Yeah, we'll take a break. Okay, so no, it's easy and breezy. Really, it's very straightforward. I think we are getting better at mathematics. Okay, so that's good. Okay. Alright. Well, I gotta eat something, so okay. If you don't mind. Uh, Yeah, just cooking some leftover stuff. So we're gonna yeah, it's time to switch out this board, okay? So, uh, uh, well, we are doing this because just because, okay? We're kind of bored, you know. I am. I got there's nothing going on in this nice weekend. Okay, so let's see if it sticks. No? How about this guy? Yeah. Okay. Good. Because this tray is not very well working, so I'll just get rid of that tray. Okay. Good. Man, I'm hungry. I will eat right in front of you. Okay, I'm sorry. It's not going to be a very pretty scene, but yeah, can you erase this? Because they figured it out like 500 years ago. You know the foul harbor formula. Okay, or somebody called it Bernoulli's formula, but whatever, right? Two different mathematicians. Yeah, so they got our back. Okay, so it's all covered. Bernoulli number, whatever, Starling's number. Oh, it's way beyond me. Okay, so let's rewrite that equation. Okay, uh, you know, I better have that tray because I need that tray. Okay, so where's that tray? Yeah. I mean, it falls apart so easily. It's so cheap. There. Okay. Give me 1 second. Okay, I'll be right back. Okay, because I'm hungry, so I'll eat this thing very quickly and then. Okay, we're back. I had some food and warm milk. I was hungry, okay, so. Okay, let's continue, shall we? With nice tray here. So, um, just rewrite. Ugh, it's too light. Can you see this? Yeah, you can. This is a nice formula actually. There's some symmetry there, right? I with n plus I with n minus I. Okay. Why don't I write that? It's just to make it look similar. Okay. That's our palindrome number formula. Okay. It's very straightforward. Okay, as opposed to like Bernoulli number, man. I have no idea. It's maybe one day I will try to learn that thing, but it was beyond me, way beyond me, really. Okay, it was too much. Okay, so I stopped studying that thing. Okay, so okay, so now that I ate something, now it's generating all this heat. Plus, I'm drinking warm milk, so. Alright. So, what did I just eat? Yeah, it's some leftover from. I went to a restaurant in the morning. It's kind of like political meeting, actually, okay? So, because I go to political meeting every now and then when I want to have nice breakfast. Yeah, so it's toast, wheat bread, no butter. I wouldn't mind if they put butter. Actually, I kind of wished that they did put some butter in there because otherwise I never eat butter. Okay, I love butter. Okay, so but I just don't eat it. But if you had they put some butter in there, yeah, I would still eat it. Okay, because yeah, it's delicious. Okay, but I wouldn't ask them to put butter in there. Okay, so I'm gonna take a picture of this and then it's kind of pretty. Did I take a picture of this before? I guess I may have. Whatever. Okay. Ah. So let's verify this real quick, okay? When I is equal to 5, sigma 1 to 4, 5 minus I, 10 to the I plus 5. Right, you got it. Yeah, it's kind of the power up there, the exponent is growing in a linear fashion, and that's very well expected, right? As n grows. Yeah, because it's like you're adding two digits, two digits, two digits. Okay, so yeah, it's supposed to be like this. All right. Yeah. Now we need to expand this. Okay, we need to get rid of sigma. Let's work it out. All right. So how about this brown? Is this good enough for you? I think so. Is equal to sigma k from 1 to n. Okay, I will leave this guy alone for now because we're gonna expand this. So this is what? This part, okay? We'll just be diligent and just write it all out, okay? N times 10 to the nth times the first term, okay? 10 to the ith minus I times 10 to the nth times 10 to the ith, okay? That's what we got. Which is equal to, now we're gonna prove out 1, okay? So sigma, well, we better start from far left so that we have a lot of room, okay? So a to the n, an is equal to sigma, okay, k from n to n minus 1, okay? Because we're gonna spit out one the last term, okay? When k, boy, I'm sorry. I gotta take a picture of this again because it's not k, it's I. My bad. Well, we'll take a picture later. Okay, so sorry. When I is equal to n, okay. Yeah, we're splitting out the last term, okay? So n times 10 to the n, okay? So okay. There are two separate terms, okay? Two separate terms. This whole thing, okay? They're separate. Now, plus, let's see what we got here. N is a constant, okay? It's sigma variable is just I. I is the sigma variable, so all the constant can get out of the sigma, okay? So if n times 10 to the nth sigma I from 1 to n minus 1, 10 to the ith, okay? We have same thing, kind of, okay? So we can factor this, all right? No, it's not the same. Because, yeah, they're not the same, sorry. Minus 10 to the nth sigma 10 to the 8th times sigma I from 1 to n minus 1 I times 10 to the ith, okay? So which is kind of look like this guy, okay? So these two guys have this common sigma, okay? So we can factor this, all right? I forgot the formula for this guy, so I have to redrive that formula, okay? I times 10 to the I, sigma of that, okay? It's not that difficult, so let's just write it one more time, okay? So factor this out, okay? So you have a 1 minus 10 to the nth, right? And then sigma I from 1 to n minus 1 I times 10 to the ith plus n times 10 to the nth times sigma I from 1 to n minus 1 10 to the ith plus n times 10 to the nth, okay? So this an, okay? it's as simple as it gets. Okay, so now I gotta rederive this formula, and then this is just geometric series, so that's easy. So that way we can get rid of sigma. Okay, okay, so we are getting there. All right, so yeah, fairly straightforward, right? Okay, let's take a picture of this, and we'll take a break. Ooh. Okay. Whew. We'll be back. Okay, so. Okay. Oh boy. Okay, we will be back. Okay, let me wash my face. All right, we're back. Uh, yeah, we gotta switch out the board. Who do I erase now? Yeah, let's erase this guy. Old board, the oldest board, non-magnetic board. Oh well. Yes, stable tray, so that's good. Okay, I'm gonna erase all this. Crap. I was hesitating to use that term, okay, so it's because it's not, it's maybe it's a gold. Maybe, you know, knowledge is gold or better than gold. But whatever. My handwriting sucks, so yeah. I think it's okay to call it crap. Oh well. Okay. Let's. I don't want to show you bottom of this milk because I don't want to gross you out, but yeah, like the food I eat, it's very very ghetto. Okay, so I'm sure prison inmates they eat better than I do. Okay, because I have this what soup, right? Because I put water in there and I cook some food there, and then there's always leftover this liquid, you know. I just reuse it over and over. I put it in the fridge and put some more stuff and cook it in the microwave, and I just reuse that soup over and over again. Okay, so if if water dries out, then I put some more water, whatever. Okay, so it's not that pretty, but it's healthy. Okay, that's what matters. Okay, so same thing with milk. Okay, so at the bottom, yeah, there's some food particle. Yeah, sure, food particle, whatever. Okay, I'm sorry. Yeah, I'm ghetto like that. So, but in terms of health, it's a lot healthier because yeah, the bacteria, whatever, edible bacteria. Okay, so it's good for your gut. Okay, so yeah, like fermented food, kind of. Okay, I'm sorry. Okay, so what is sigma I from 1 to n, a to the ith? That's geometric series, right? A plus a to the second plus blah 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 plus a to the nth, right? So let's call this Sn, okay? A times Sn, we just call it S, okay? S, okay? A times S is equal to a to the second plus a to the third plus blah 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 plus a to the n plus first, okay? And we subtract that. Then this guy cancels out, this guy cancels out, like this. So 1 minus a, I'm sorry, s is equal to a minus a n plus 1 over 1 minus a. Okay? We are subtracting these two equations. Okay, so okay, so that's the formula. Okay? So using this formula, okay, we have what? Sigma I from 1 to n minus 1, 10 to the ith, right? This is what? A is equal to 10, right? So, and n where it's n minus 1. So it will be 1 minus 10 over 10 minus 10 to the n. Okay? You're just plugging in, okay? So n minus 1 plus 1 is just n, right? So which is 10 to the nth minus 10 over 9. Okay? Easy, right? Yeah. Now, next step. We have, okay, another something that very similar to this, okay? We just keep calling it s, okay? Sigma I from 1 to n I times a to the ith, okay, is equal to 1 times a to the first plus 2 times a to the second plus dot 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 plus n times a to the nth, right? Now we multiply by a just like before, okay? A times s is equal to 1 times a to the second plus 2 times a to the third plus dot 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 plus n times a to the n plus first, okay? Subtract it. So s is equal to 1 minus a, go downstairs, upstairs, it's like a to the first plus a to the second plus dot 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 plus a to the nth minus n times a to the n plus first, okay? And we have right here, okay, which is equal to this guy, okay? So you have 1 minus a downstairs, right? Upstairs, we just have this, okay? So a plus a squared plus blah blah plus a n, okay? So we just have that. So a minus a to the n plus first over 1 minus a minus n times a to the n plus first, okay? So we have that. To simplify this, oh boy, we have 1 minus a squared, okay? Okay? We're running out of space, but okay, so this guy is equal to yeah, it's whatever. Yeah, we cannot simplify. Yeah, we can simplify this further. Yeah, it's very not very pretty a formula, but well, it is what it is. So, um, who says life is always prettier? You know. Yeah, but at the bottom of this milk, it's not food particle. Then what are they? It's just pepper and when you microwave or boil milk, at on top there's this what some kind of like cheese, kind of probably protein. Okay, so that's what's down there. It's not food particle. That's not true. Okay, so it's just some pepper. Sometimes many times I put some stuff in the milk before I microwave, like pe- red pepper, some garlic powder, or parsley, whatever. Okay, so that's what's down there. It's not food particle out of my mouth. No, I wouldn't drink that shit. Okay, I'm not that bad, but probably your dog, your cat eat better than I do. Okay, so but what I eat, yeah, it's not pretty, but it's healthy. So okay, we're gonna have to test this out because it's highly complicated formula. So let's say n equal 1 and a is equal to 10. Okay, we'll test this out. Okay, it should give us 10. So n equal 1, okay, and a is equal to 10. So well, actually we'll do a is equal to 2. Okay, so we have 1 here, so it should give us 2. Okay, 2 to the first. All right, and n is equal to 1, and so 2 to the third minus 2 times uh, 2 times 2 to the second plus 2. So yeah, it works. Which is 2. Okay, so okay, I think this is correct formula. Okay, so not a very pretty formula. Okay, so I better write this down in my notebook. Okay, because it's good to have this pencil and paper notebook so that I don't have to reinvent the wheel every single time. Okay, so I used to just take pictures, but I mean, I erase, empty out my picture gallery in my cell phone storage on a regular basis. So with this pencil and paper, yeah, it's a good idea to have this. Also, this formula could be wrong. Who knows? So we can always check back on that. So we have that, and we have also this. Okay, okay, we got the formula. Phew. Okay. All right. So we got the formula. Good. Okay. Now we have to pick another board to erase. I'm gonna get this milk out of here. Okay, it's so annoying. Put it back in the fridge. It makes me self-conscious. I'm sorry if I kind of grossed you out. I'm sorry about that. Okay, but hey, it's food. Um, all right. very good looking board. Ah, boy. I have 3 kinds of boards here. By now, I have 7 boards. 7. Okay. Alright, so. Yeah, just drinking water. So where are we? I just rewrite the formula that we are trying to simplify. Okay, so an is equal to, can you see this? Okay, 1 minus 10 to the nth multiplied by sigma I from 1 to n minus 1 I times 10 to the ith plus n times 10 to the nth sigma I from 1 to n minus 1 10 to the ith plus n times 10 to the nth. Okay, so we just plug in that formula. Okay, well, I'll read from my note. Okay, so which is equal to 1 minus 10 to the nth. Okay, okay, so and multiply by this guy. Okay, so I'm just plugging in the number. N minus 1 times a to the n plus 1. Downstairs we have 1 minus a, what is a? 10, so yeah, 81. I have a better idea. Let's get this 81 guy out of the way so that we don't have to write the fraction. Okay, long fraction, we don't want that. Okay, so 81. Okay. Oh, my shoulder. It's just shoulder muscle. Oh, minus n times, well, a we know is 10, so ten to the nth plus 10. Okay, all right, we have that plus now this guy you, what, 10 times it will be minus. Okay, minus n times 10 to the n over 9. Okay, so ten minus 10 to the nth. Okay, that's it. Okay, so now we need to simplify this formula. Once we have simplified it, we just need to verify by plugging, making some examples. Okay, that's all we have to do. Oh boy. It's, yeah, it's a lot of work, but nothing too difficult. Okay, so just algebra. Okay, it's very mechanical from now. We just need to simplify this thing. Okay, so you have 10 to the nth, right? There's a common factor there, so you have 10n minus 10. Okay, I'm speeding out 110 here. Okay, so 10n minus 10 minus n. So 10n minus n is 9n. Okay, then you have minus 10 here. Okay, plus 10. Minus you have 9 here, and upstairs you multiply by 9. Okay, so n times 10 to the n. Yeah, you have that. So you have 9. Minus 10n times n to the 10 to the nth. So minus 10n times 10 to the n. So okay. Oh boy. Let's expand this, shall we? It's not going to be easy. It's not going to be. It's easy. It just takes a long time. Okay, it's very tedious kind of thing, and it's going to be very long. Okay, so you have what? 9n times 10 to the nth, right? Minus 10 to the n plus first plus 10, and you multiply 10 to the nth for each of those things. Minus 10 to the nth. So we minus 9 times n times 10 to the 2n, right? Yeah. Plus, I'm just expanding this guy. Okay, so 10 to the 2n plus 1 minus 10 to the n plus 1. Okay, now you multiply 9 here, so minus 9 times n times 10 to the n plus 9n times 10 to the 2n. Okay, okay. Wow, look at this. This guy cancels out. That's good. This guy cancels out again. Okay, good. What we are left with is 10 to the 2n plus 1 minus 2 times 10 to the n plus 1 plus 10 over 81 divide by 10. Okay, so yeah, it's kind of deja vu, right? Yeah, we saw some formula that kind of looks like this. Hundred to the nth minus 2 times 10 to the nth plus 1. Yeah, we've seen something like this before. Okay, so it's a kind of deja vu kind of deal. Okay, so I'm gonna write this down. Okay, this palindromic number. Okay, it's super palindrome number. Okay, so super palindrome number. That's mountain palindrome mountain. Okay, mountain palindrome. How about that? Mountain palindrome number. Okay, so mountain palindrome number. We call it just MPN. All right. Mountain palindrome number is 100 to the nth minus 2 times 100 2 times 10 to the nth plus 1 over 81, and we will make a few examples so that I didn't make any mistake. Okay, because I did a lot of calculation in my head, right, as I'm doing this. So I may have made some mistakes. Okay, so we'll take a break and we'll be back. Okay, so all right. Oh boy. Yeah. Okay, we're back. If you noticed, yeah, I'm not drinking because I drank too much already earlier today. So, where's my glasses? Oh, my lips get so dry. I'm getting old, I guess. Okay, let's make a few examples, shall we? Let's do when n is equal to 2. Okay. Okay. When n is equal to 2. Okay, so this pen they need to go away to make some room here. When n is equal to 2. Okay, so my goodness, with what 100 to the what 10,000. Okay, we have 10,000 minus 2 times, we have 200, right? N is equal to 2 plus 1 over 81. I mean 8.1. This supposed to be what we have, what 0 1 2 1. It's supposed to be like that. So yeah, 11 times 11 times 10, right? Oh boy, it's supposed to be that, but so 200, so you have 9 8 0 1. Yeah, it's divisible by 9, so that's a good news. 8.1, which is what 0.9 1 0 8 9. Again, divisible by 9, so 0.1 1 2 1. Yeah, we got it. Okay, so yeah, it is indeed 1 2 1 0. So I think we got the correct formula. Okay, this time. Okay. Oh boy. Yeah. I mean, we can prove by mathematical induction and whatnot, right? But we are not going to. Okay, because I leave it to some other people or to you. Okay, because yeah, we had enough fun with mathematical induction. Okay, so okay. Um, okay, we got it. All right, so I don't see any need to take a picture of this. Okay, so so this is the uh, palindrome, mountain palindrome number. Okay. Now our next job is to figure out the palindrome constant. Okay. There will be our next step. Okay, so oh boy. I'm kind of being fed up with all this. I'm it's getting old, yeah, really. Because it's just too mechanical, you know. Oh boy. I'm being fed up, really. Oh, but we better finish what we started, right? So, well, we may want to take a different path. Okay, we'll kind of make a different approach, because I tell you why. All right, so we take a different approach. Okay, so okay, let's switch out the board. Okay. Oh boy. Because now that we have handed in the formula back there, also in my, did I write that number down? Yes, I did. Now that we have this mountain palindrome formula, okay, so which is I just write it at the corner, okay, so mountain palindrome number, okay, is what, 100 to the nth minus 2 times 10 to the nth plus 1 over 8.1, okay. Nice formula, really. Okay, so we have that, and this one goes like what? What if n is 0? Let's do it really okay. 1 minus n is equal to 0 plus 1 over 8.1 is equal to what? 0. Yeah, so it even works when n is equal to 0, okay, so that's good. This number goes like this, okay, so 0, 1, 0, 1, 2. Wait a minute, something's not right. This is not palindrome number yet. Okay, let's make a few examples, okay, so okay, 0, 0, 1, 0, 0, 1, 2, 1, 0. Yeah, so this is nth palindrome number. Okay, so it's not mountain palindrome number yet. We just found out. Okay, but n is equal to 1. Okay, let's do it real quick. Okay, 100 minus 20 plus 1 over 8.1 is equal to 81. Yeah, 10. So yeah, it's nth palindrome number. That's what this guy is. It's not mountain yet, because to build a mountain, we have to do another sigma. Okay, and which is very easy. Okay, which is not too difficult. Okay, so if you like, let's do one more. 0, 1, 2, 3, 2, 1, 0. Okay, so so we have this palindrome pyramid, palindrome triangle, right? So to concatenate that, it's like 0, 1, 0, 1, 2, 1, 0, 1, 2, 3, 2, 1, 0. Okay, so it's like which is equal to 10 plus 1, 2, 1 multiplied by 1000, 10 to the third Yeah, 1 times 10 to the first, right? Plus 1, 2, 3, 2, 1 times 8. 1, 2, 3, 4, 5, 6, 7. Uh, yeah, I think it's a quadratic increase because the number of digits is what? One digit, two digit, three digit. I'm sorry. Number of digits, okay? One digit, three digit, five digit, seven digits, right? So um, instead of subtracting, we used to do that, like to calculate the velocity, to calculate the acceleration. We used to subtract them, right? Now we're gonna add, okay? So it's like kind of integration kind of concept. You add this together, become a 4, right? And 4 plus 5, you add them together, 9. And 9 plus 7, yeah, 16, right? You're just adding them up, okay? I think it has to be quadratic formula, okay? Second order, okay? Because we are adding up numbers, okay? So we just do one more, okay? So 1, 2, 3, 4, 5, 3, 2, 1, 0. Okay, so plus 1, 2, 3, 4, 3, 2, 1 times 10 to the, so this guy was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Okay, so okay, we are just calculating the exponent. Okay, so 1, 3, 7, 13. Okay, now let's subtract it. Okay, so 2, 4, 6, 2, 2. Okay, we got it. Okay, so dot 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 and nth. What would be nth? First, second, third. Well, yeah, what would be nth? We have nice formula for this, right? Well, 0, 1, 2, 3, n minus first. N minus first term, okay? So it's just easier that way. What is it? S is equal to S0, which is 1. And to find V0, we have to go one step backward, okay? And find the average of that, okay? So it'll be 2, right? So minus first, it'll be 1. Okay, so velocity, average velocity between 0 and 2 is 1. Okay, so V0 t plus, yeah, 1 half at squared, right? So a is 2, so it's just t squared. Okay, so sounds looks familiar? Yeah. T squared plus t plus 1 is like our pretty pinky finger, okay, of our monster baby. So yeah, it's a deja vu. We've seen this before. Okay, so okay. So let's plug in the number. Okay, so now, but we want to start indexing from 1. So we have to parallel shift. Okay, so we gotta plug in t minus 1. Okay, so s is equal to what? K minus 1 squared uh, plus k minus 1 plus 1 is what? K squared minus k plus 1. Okay, so and then the index can start from 1. Okay, so 1, this 1, 2, 4 minus 2 is 2, yeah, 3, 3, 9 minus 3, 6 plus 1, 7. Okay, we got it. Okay, so yeah. Okay, yeah. So then our mountain palindrome number will be this. And you have a 10, 121, and 1, 2, 3, 2, 1, 0, right? So we have to divide by 10, okay? So our mountain, let's take a shot at it, okay? So mountain palindrome number is equal to sigma, okay? I is from 1 to n. We have to divide by 10, right? So multiply by 1 over 10, so 81. Hundred to the ith minus 2 times 10 to the ith plus 1, right? Multiply by 10 to the I squared minus I plus 1. Okay, so yeah, that's our mountain palindrome number. Okay, probably this formula is correct. Correct, probably. Okay, so we'll make a few examples, and then our next step would be to simplify this guy to get rid of sigma. Okay, I'm not even sure if that's possible because we have 10 to the I squared. That's, I don't know if that kind of formula even exists. Sigma 10 to the I squared. I'm not sure if that kind of formula even exists. Okay, I haven't seen one. Maybe it does. I don't know. So maybe it's not that necessary we get rid of sigma. Okay. Yeah, it's not very pretty, but well. I mean, I don't even know how to go about it. Okay, so sigma, you have what? Sigma 10 to the I squared. I mean, it's like power of power, you know. I'm not sure if there is a formula for this. I mean, I don't even want to think about it, to be honest with you. My goodness. I from 1 to n, okay? I don't even want to think about it, okay? It's like, maybe there's formula, right? I don't know. It's, I don't even want to think about it, okay? It's just, I mean, it's not too necessary that we get rid of sigma, okay? It's better if we get rid of it. But if we can't, or if it's just too difficult, we just leave it there. Okay, so our goal is to construct this palindromic constant, which is mirror image of this. We are going right now. We are going to the infinity, right, to the left side of this decimal point. But we're gonna do about face. We'll make it so that we're gonna like flip it 180 degrees to the right of this decimal point right here. Okay, and that's our goal, and we'll try to make use of this guy. All right, well, first we have to verify if this formula is correct, but probably it is because we've seen this kind of pattern before, right? But we'll verify it anyway. Okay, so maybe tomorrow. How about that? Yeah, it's getting really boring. Okay, so we have uh, I gotta erase this because this is not, yeah, it's just palindrome number, the mountain palindrome number. I have to go to the next page. Let me write this down, okay? So MPN is equal to sigma I from 1 to n. Okay, so I wrote it down. So I don't think it's necessary that I take a picture of this because now I have pencil and paper, so. Okay. We'll just do two examples when I is equal to 0, okay? So, I mean, yeah, then what? Become 0, right? So, yeah, so that's that. When I is n is equal to 1, I is 1, right? So, 100 minus 2 plus 1. Yeah, that become 1. 100 minus 20 plus 1, yeah, so 1, and then, yeah, 10. Okay, so let's do one more, okay? So, n is equal to 2, okay? Boy. So you have 10, right? So it should give us what 1200. Okay, so I'm gonna do it in my paper. Okay, just to verify this is correct or not. Okay, so no, I don't want to waste my paper. Okay, this is a notebook. It's not scrap. It's not. This is not scrap paper. No. So I'm gonna use another board. I'm gonna switch out the board and yeah, I'm gonna switch out that board over there because I don't need that board anymore. All right, here. We'll just make one more example, then we'll call it a day, okay? Because yeah, I don't have many things going on, but maybe I study Russian or something. Okay, so when n I is equal to 2, my goodness. Ten to the 4 minus 2 plus 1. Okay, this should give us what? 1200, okay? Nine eight zero one divided by 81 times 1000, okay? 910. Sorry, yeah. Okay, I guess I'm kind of off. All right, so yeah, I made a mistake somewhere. Okay, so I have one more zero than I need. Okay, so I obviously made a mistake somewhere. Ain't that a bitch? Son of a gun. Oh boy. Ah. Hmm. Let's do our palindrome number formula, okay? When n is 100 minus 20 plus 1 over 8.1 is equal to what? This is 81 over 8.1, which is 10, right? So, and if I divide by 10, then it becomes 1. Actually, this is correct. Yeah, I'm sorry. Yeah, this is correct. Because we are doing palindrome mountain, right? Palindrome mountain. So, yeah, 0, 1, 0, uh, 1, 2, 1. Yeah, so it is correct. I'm sorry. Yeah, we got the right formula. Okay, so, yeah, because we are doing palindrome mountain. Okay, yeah, it's sorry. Yeah, mistake of mistake, whatever. We got the right formula. Okay, so it is correct formula. Ah, boy. So now, yeah, I think that formula is correct. Okay, so let's move on. What? Sharpe-Noni number, right? It's like Sharpe-Noni constant is like 1.0.12 0 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, blah blah. This Sharpe-Noni constant, right? Um, but we can flip it around, right? 180 degree, okay? Then it becomes like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah blah blah. Okay, you can go the other way. Okay, yeah, we call it reverse Sharpe-Noni number, whatever. Okay, so it's, yeah, it's just go to infinity, of course. But so how can we do that? I mean, mathematically. Okay, so or you can also have symmetry kind of palindromic number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah blah blah. Yeah, you can do that, right? To make it palindromic, symmetric, right? But yeah, because it's easier than our palindrome number. Okay, so that's why we are doing this. Sharpen-Noni instead. Okay, step by step. All right, so okay, so that shouldn't be that very difficult actually. It shouldn't be difficult at all. All right, so now let's do this palindrome mountain. Okay, so we're climbing the mountain. Okay, what? 0, 1, 0, 1, 2, 1, 0, 1, 2, 3, 2, 1, blah blah. Okay, it's it's easy. I mean, 2 is like you have 10, right? And then 1, 2, 1, 0, 0, 0. And then you have 1, 2, 3, 2, 1, 0, 0, 0, 0, 0, 0, 0. Okay? It's good that they are palindromic. Okay? Because all we gotta do is just work out the digits, like 10 to the, so we want to multiply this guy, we want to make this as a 0, 1, and we want to make this as 0, 0, 0, 1, 2, 1. It's good that it's palindromic, because otherwise, flipping to the other side, it could be a nightmare, okay? But now that we have palindromic, which is symmetric itself, we are making this into what? 0, 0.00 0, 0, 0, 0, 0, 1, 2, 3, 2, 1, right? So here we need to multiply this by what? 1, 2, 3. So 10 times 10 times I need some space, so 10 times 10 to the 1, 2, 3, 10 to the minus 3, okay? Here you have what? 1, 2, 1, 0, 0, 0 times 10 to the minus, okay, 1, 2, 3, okay, so it goes like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the minus 9, okay. Okay, so here you have what? This big number, right? 1, 2, 3, 2, 1, 0, 0, 0, 0, 0, 0, 0, okay? Times 10 to the minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the minus 19. Okay, so, oh boy. Probably we'll have to do what? Just one more. Okay, so you have what? 1, 2, 3, 4, 3, 2, 1. And how many zeros are there? I just write it out. Okay, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 3, 2, 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 31. Okay, so 10 to the minus 31. Okay, so okay, you have 3, 9, 19, 31. Okay, subtract 6, 10, 12, Okay. Wait a minute. Oh. Hmm. It shouldn't be very difficult to calculate this. It shouldn't be. All right. So it shouldn't be. Just number of digits. Okay. How does it grow? Out. That's what. I mean, the number of zeros. Okay. You have one zero. The first palindromic number, right? One zero. Then you have three zeros. Then you have what? Seven zeros. And then you have 7 plus 5, 12 zero. Okay, so 2, 4, 5. Okay, that's strange. I made a mistake, didn't I? There's one more here. Okay, so this should be 32. 33. Okay, so 33. So, and this is 14. Now it makes sense. Okay, its acceleration is 4. Okay, so 33. There's one more zero here too. Okay, so now it makes sense. Okay, so yeah. So what is this formula then? Yeah, we gotta go back, right? So what? S equal to well, we gotta go. We use the formula that we came up with before. Okay, so this time zero, right? Okay, so halfway between 2 and 6 is the momentary instant velocity of 4. Okay, s equal to 3 plus 4 times t. Well, we just use k. Okay, so 4 times k plus half of this is 2, right? 2k squared, and we're gonna do parallel shifting, right? So subtract 1, so s is equal to 4k minus 1 plus 2k minus 1 squared plus 3. Okay, which is equal to 2k squared minus 4k, so they cancels out. 2, 3, something like this. Okay, let's see. Yeah, k is 1, 3, k is 2, 9, k is 3, 19, k is 4, yeah, 33. We got it. Okay, we are almost there, my friends. Okay, so our so if we add this up, it makes our palindrome number, right? Mountain palindrome number, right? And so but before we add them up, this is a ith term inside of that palindrome mountain number. Yeah, I'm waving hand a lot, but I'll share this with you, okay, once we figure this out, okay? So we are almost there. We are very close, okay? So all we're gonna do is this, okay? So our palindrome constant, okay? Let's say mountain palindrome constant, okay, is equal to sigma I from 1 to n 100 to the ith minus 2 times 10 to the ith plus 1 over 81. Oh, yeah, well, I wrote it right here. So, okay, multiply by 10 to the I squared minus I plus 1. That was our mountain palindrome number. Now we are doing mountain palindrome constant. All we gotta do is insert 10 to the minus 2k squared minus 1. Okay, that's all we need. Okay, and then we add them up. Then, ladies and gentlemen, we have, we have our palindrome constant, ladies and gentlemen. Okay, so yeah, we can simplify this, right? Let's do it real quick. Okay, so I will take a picture of this because this is nice. Ta-da! Okay. And tomorrow we'll make some example and see actually this works. Okay, but I have a good feeling about this. Okay, so even if I made some mistake, which I do many times, it's no big deal because we got it. Okay, so we got the logic down. Okay, so it's just yeah, and like, but if it's good that it's palindromic number because if it's like non-palindromic number and we want to make what reflection of that, like for example, let's see like number 24. Okay, reflection of that is 0.42. That's a lot difficult because we have to break down 4 and 2, right? So, or maybe it's not that difficult. 1 to 4, 4 to 1. All we gotta do is instead of multiplying by 1, 10, 100, we need to multiply this by 10 to the minus 1, 10 to the minus 2, 10 to the minus 3. Okay, so see, I guess it's not that difficult. Okay, so to make reflection around this decimal point. Okay. Well, this is plus 1, by the way. Here. Okay. So I'm gonna take a picture of this and we'll call it a day. Oh, we did a lot. This episode I didn't drink single drop of alcohol. Okay, so okay. just take a picture of this and I'm gonna write that down too. Yeah, I'll share this with you tomorrow, okay? I'll write it big so that you can see it. Yeah. So yeah, we got it, okay? I just need to write this down. So we have mountain palindrome number and we have mountain palindrome constant. Okay. All right. Thank you for your patience, and I hope you enjoyed some part of it. Okay. Yeah. Yeah. Compared to like Bernoulli number or Stallings number, oh boy, this should be a lot easier than those. Bernoulli number, I still don't know. Maybe I will study that because I'm not sleepy. Maybe I just Google around, being around in the cell phone, and maybe I just study that. So I'm not sleepy. Okay, so all right, thank you. Yeah, I'll try to study Bernoulli number or Russian language or whatever. Okay, thank you. Bye. Thank you.